I'm Dean Savola, and this is the Azure Academy. So today we're going to be continuing our series on automation. And what we're going to do today is we're going to build a couple virtual machines, and we're going to make them highly available with a load balancer. And we're going to make them into web servers. And then after that, we're going to tear the whole thing down and redo it in automation. So this is a general good principle to start off with. We want to start by building things in the portal, and then when we build them, that will then give us the information that we need in order to be able to create the automation. So whenever you start building a new item, something you haven't dealt with before, you want to start by doing it in the portal, because the portal is very easy to work with. So for example, we're going to start off building a virtual network. Now we've done these before, and we'll hit create, and we'll say that this is a web demo VNet, and we'll leave the rest of these as is. Oh, need a resource group. That'll help, because every resource has to go in a resource group. Okay. And that is deploying. And we could either click on it here to go watch the deployment, or in the deployment section of the resource group. And this will be done in a few seconds. Okay, so now we have our virtual network. And now we're going to need a few other items, beginning with a virtual machine. Then we're going to need an availability set for that. And then we're also going to need load balancers, and then we'll have to build a second virtual machine. So we're going to make this a Windows system, and we'll call this Web VM 0. And we'll put it in our resource group. And I'll select yes, that I want to save some money with the Azure Hybrid Use benefit. And this is where, if you have Windows licenses already, that by checking this box, you confirm that your current licenses cover the cost of the license of this virtual machine, so you don't have to pay for it, so you can save some money when you provision these resources in the cloud. And I'm going to build this as a F2, because I like the performance of that. And we're going to create ourselves a new availability set. Web-AV set, and the default values are fine for our fault and update domain there. We will be using managed disk, and we'll be doing it on our current existing subnet, but we are not going to provision a public IP address, because that will be assigned to our load balancer, but we will need to have HTTP and RDP allowed through our network security group. So we're going to have each VM have one network card. That network card will have a network security group attached to it. And then we will be putting that behind a load balancer. So then the public IP address will be required on the load balancer. All right, and we'll leave the rest of these as is, and using our default storage account here for diagnostics. All right, so we're going to hit create, and our first VM is off and running. Now, one thing that I want you to take note of as we look at our deployments, and that's go ahead and building, is when we look at our template, what we're actually provisioning here is a virtual machine, availability set, network card, and network security group. Now, as we look at this template, you see we have a parameters section, which has a lot of inputs, and we can see those inputs either over here on the input screen, or we could click on parameters here, and that will show us the inputs. And these inputs they're not exactly intuitive, They're not exactly easy to know what you should put in there if you've never done it before. For example, the biggest one being this diagnostic storage account resource ID. You would not be able to figure that out on your own. So when we're writing our automation, what we want to do is make things as simple for the end user as possible, accounting for the scope of what it is we're actually automating, meaning are we automating everything that's in this resource group, or just parts of it and counting on other parts to be present first. For example, it's very common to deploy a virtual network and have that in place with your routing rules and security groups and all of that, and then on top of that, provision virtual machines, because you have a specific configuration for your virtual machine, and that has to be done time after time after time, but you only had to build your virtual network once. So it's common to keep those kind of things separate. Also, if you have a separate security stack or central services that are provisioned, that's going to be different from deploying an app server. Okay, so when you have that app server that you need to deploy, like in this case, we're provisioning 2 web servers, and they could just as easily be app servers or database servers, then you want to make the inputs as simple for the user and as intuitive as possible, giving them as few chances to make mistakes so that they provision things according to your standards. Okay, so we want to keep pushing this DevOps mindset of continuous integration, continuous improvement. We want to move fast, we want to be agile, but that also means we have to allow for the fact that we sometimes will fail fast. Okay, and that's good if we learn from it and can move on and recover. And that's the point of DevOps. So coming back to our template here, we can wait for this system to be done, which will probably be another minute or 2, or we could go ahead and provision right now our second VM. And we're going to do that. So you've already seen us deploy the VM through the portal, but now I'm going to show you the first kind of portal automation. So yeah, actually, let me go back to our overview here for a second. So see this redeploy button? When this build is complete, you can hit redeploy and it'll ask you the questions that you need to enter to deploy this thing all over again. Or we could not wait, click on our template here, and hit deploy. And that's going to give us the same process. So you get a screen that looks like this, which we've done this before. And we select our resource group. And you see most of these things are already filled out for us, but they are filled out for the VM that we already built. So if we just do this again, we will still only have 1 VM. So we need to change some values here. So we'll change this to be VM1, and we'll leave it on the same virtual network, and we'll have to change the network interface name. So let's change this to webvm1-nic, and leaving the same NSG for 2 VMs if they're in the same role is okay. So we can have more than one NIC attached to an NSG, and if they're in the same role for the same app, they need the same rules. So why not just use the same one over and over? And then we'll put in our password, and we'll leave it in the same availability set, again, because it's the same kind of system that's in the same tier, and it's going to need to be as highly available, and the availability set will mean that the VM0 will be put into one server rack, VM1 will be put into a separate server rack to make them highly available on the Azure side, and we're not going to change our values for our fault and update domain. We'll leave it in the same diagnostic storage account, and our ID, which was long and ugly for us to put in, is already present for us, so no extra work needed, and we're deploying it to the same subnet. So there we go. We've done simple automation through the portal. All right, and you could just keep that process going over and over. And you see these resources finished straight away because they already existed. Okay, and now we've built our network card, and we're going to go on provisioning VM1 from there. And VM0 has finished. So that's good. And we still have these long names for the disks, so I don't really like that. I'd prefer it conform to a proper naming standard that I have. So I'm going to want to change that when I do the automation, as well as this original network card. I'm going to want it to conform to my naming standard like I have for my second NIC. The NSG name is okay, the VM names are okay, and of course I typed in the virtual network name, so I like that. So we have to wait for that to finish, but in the meantime, let's provision ourselves a load balancer. So in the marketplace, we type load balancer, and we create that. Now there are a few different kinds of load balancers. So there is a internal load balancer and a public load balancer. The difference being public has a public front end or public IP address, and the internal does not. It only has an IP address on your local virtual network subnet. And there are also two SKUs. And the SKU that we're going to use is basic because basic supports public IPs. Standard today does not support public IPs, but standard has another advantage of having highly available ports or HA ports. The benefit of that is I don't have to know or call out every single port I need this load balancer to balance for me across multiple systems. I can just tell it HA ports and it will balance all traffic that comes in from the backend systems automatically, which is very nice. I believe that the feature of standard load balancers with public IP addresses would be coming in the future, but I don't know for sure, so keep your eyes open on Azure updates for that. So let's give this guy a name, and it's our Azure Academy. It's a web load balancer, and ILB is for load balancer. And then we're going to keep it as public and basic, and so we'll create a public IP address. And that will also be in the basic SKU. And this is important because when you have a standard resource, like a load balancer, then the SKU that the public IP address has must also be standard. Okay? So when you have basic, it has to be basic. They have to match because they're two different APIs worth of technology, and so you've got to use the one that works with the other. And then we'll put it back in our web demo resource group, and the rest of this is fine. Now, we're not done with creating this load balancer because there are several components that it needs to have configured. And let's check in on our deployment. So the deployment of our second web server is still ongoing. And this brings us to another layer of automation that we can add to our VMs. So if we go to web VM 0, we have this blade here for extensions. Now, extensions, if you remember from our fundamentals course, are bits of automation code that we can add on as services or as functions. So, for example, we have several different services here. We have our Network Watcher Agent, Microsoft Anti-Malware Protection, GPU drivers if you're using a VM that has NVIDIA GPUs, CloudLink, which is a disk encryption tool. We have Chef, we have Puppet, we have agents for monitoring, and we have PowerShell desired state configuration, which works like Puppet and Chef. And then we have Kaspersky, which is a antivirus software, and then we have a couple backup tools, and then we have this guy, the custom script extension. So custom script extension will allow you to pass a PowerShell script to your system and then configure it or make a change, install some software, whatever it is that you'd like to do. So in order for this to work, we have to pass it a PowerShell file. So if we click on and then we're going to select our AA install IIS. So if we look at this, it's just a simple PowerShell command that is install Windows feature of web server and include management tools. So not very complicated. And that does not need any additional arguments, but if you did, you could. So for example, I could put the dash install management tools here, but since I have it in the script, I don't need to. And we'll hit OK for that. And that's going to go off and create. And it looks like our other VM is done, and our load balancer has been stood up. And here's the Azure load balancer. Now there are, as I said, several other things in here that we have to configure. So here's our front end IP, which is using our Azure public IP address. We have to create ourselves a back end pool. Now a pool is where the network cards from the VMs that we want in this pool are going to sit. So remember that a virtual network has network cards that live on subnets. The network card is not the virtual machine. The network card is attached to the virtual machine, and the network card is attached to the backend pool of the load balancer. Okay, so it's not the VM exactly, it's just attached to it. So we have to create a backend pool. So we'll call this a web backend pool, and this will be for IP version 4. And we can associate this to a virtual machine scale set, which we haven't talked about yet, a single virtual machine, or to an availability set. In the standard SKU, this is slightly different, where you can attach VMs, multiple VMs, without an availability set. But in basic, it has to have an availability set. So then we will select our web availability set, and then we will plug in our virtual machines and which IP address or which network card on those virtual machines we want to add. All right, that looks good. Now, we needed this backend pool because ultimately we need some load balancing rules. But if we look at adding a load balancing rule, it says we need a backend pool and we need a probe before we can have a load balancing rule. So once this finishes updating, we will create ourselves a probe. Now, a probe is something that looks at either HTTP or TCP, and it looks at a specific port, like port 80 for a web server, and it's going to analyze that port and see, is the system in the backend pool alive on that port? If it is, the health check is good. If it is not, then there are a couple factors that it uses to judge what it should do. Okay, so one of those factors is how many seconds is it between health checks, and how many times has this system failed the health check. Okay, and we'll look at these. So when you have, it is the interval of 5 seconds by default, and a unhealthy failure of 2 times. So there could be a maximum of 10 seconds before you get failover. So if your system is hung, it's there, but it's not really responding on that port, it could be up to 10 seconds before it fails. But it will generally be much faster to respond, as you'll see in a minute. So we'll call this the web probe, and I believe it's done updating, so this should be okay. That's another thing I should bring up, is that if another process is going, like creating the backend pool or creating a probe in a load balancer, trying to update it with another feature, like adding a new probe or a load balancing rule or anything else, while it's already updating, will fail. So it can only update one thing at a time in the load balancer. So you just have to be a little patient, which is another great reason to use automation, because when we do that, we can do everything all at once. Okay, so our probe is done, and now we're going to create our load balancing rule. So we'll call this web rule 1, and it is IP version 4, and it's going to use our load balancer front end, which is a public IP address, and it's on port 80 on the front end and port 80 on the back end. And of course, we could change these if we wanted to. And it's using our backend pool that has 2 virtual machines, the health probe we just created, and then there are a few other items here. So we don't need this because we just have web servers, so we will hit OK. And while that is finishing, we've got our web VM 0 that has IIS installed, and it's got a public IP address right now because it is in our backend pool, and the backend pool is fronted by our front end pool. That's where the public IP address lives. And so what should happen if we go to this web address or this IP address, is we should get a response from our default web page, which we do. So we know that our web server on this box has been configured. That's great. Now we've got our second box, and the second box did not have that extension, so there is no web server running on that box. So what we're going to do here is we're going to reboot VM0, and we're just going to keep refreshing this page, and oh, there it goes, server's down. So we don't have a web server stood up on the second box, and our first box is now rebooted, so our website is unavailable. Okay, so this is what you don't ever want to have happen. Okay, so once we configure the second system properly, then we would see that the web server is good. Okay, it looks like we should get a response in a second, and there we are. Okay, so we see that the server went down, the server came back up. The second server did not have a web server built in, so we got no response, and that was our expected behavior. So what we want to do now that we've built all of this is we know it works. I mean, we could go ahead and install the extension on the second VM, but we know that process works. So we're good to go. We know exactly what it is that we have built, and we know that basically this is a working setup. So now we want to automate it. And we don't just want to automate the VM like we did for creating VM1. We want to automate everything. Okay, so how do we do that? I mean, that's a bunch of steps, and we'll talk about that in the next video.